In this video, we'll talk about the join operation. In the previous lecture, we saw concatenation, and concatenation combines datasets, data frames, and series by sticking them across one axis of choice. This sticking operation doesn't pay any respect to the values in the series or in the data frames. In contrast, the join operation, you can think about it as conceptually combining the data. It pays attention of what's inside the data and the value of the data in the data frames that we are joining. If you've done database before, this is very similar to the join operation in any relational database. We're going to start, and we're going to use the same helper functions that we used last time. Once again, this function is completely not related to joining data frames. Is just to help us see those data frames side by side on the notebook. We have two functions to create joins in pandas. One of them is called merge, and this is a function that we call on the package. The other one, which we will see towards the end, is a quality of life function called join, which is a function that we call on the data frame itself. Let's take a look at this example here. Here we have two data frames, df1 and df2. Now if you take a look at df1, it's basically a data frame, a table of employees and groups in a hypothetical company. And df2 is basically a table of the employee and hiring date of the employee. So if you take a look at the df1 and df2, there is a one-to-one relationship here. Each employee belongs to one department, and each employee has only one hiring date. So if we want to have one table, one data frame that contains the three columns, employee, group, and hiring date, we can simply merge them. So pd.merge df1 and df2 is basically going to give us this. Now, by default, when we do merging, Pandas is going to look at the columns here and is going to figure out that the employee column is common in between the two data frames, and thus it's going to match the values in the employee column. So if you take a look at Bob, it's going to take a look at, well, it's going to list Bob and accounting, but then it's going to consult here and figures out that Bob was hired in 2008. And if we do this, we will get 2008 here. Similarly, Jake, engineering, Jake 2012. I'm going now to show you what happens if we choose the incorrect operation, like if I do concatenation of df1 and df2 on the columns axis. Well, let's create the two data frames. Well, they need to be in a list. And that's what we get. We get the two data frames stuck together without paying any respect to the values. So we have Bob accounting and Lisa 2004, Jake engineering and Bob 2008, and so on and so forth. So obviously that's not what we want to do here. We want to merge rather than concatenate. And merging will pay attention to the values. It's basically combining the data by matching the values. Once again, by default, it matches the values in the overlapping columns across the two data frames. Let's take a look at this example here. In this example, we have two data frames. df3 contains, well, that's what we have done before. Actually, let's recreate. We have it here. Let's make sure we have this data frame here. A data frame containing the employee, the group, and the hiring date, and data frame 4, which is the supervisor of each group. Now, this is conceptually a one-to-many relationship because each supervisor is supervising multiple employees, because each supervisor belongs to a group, but a group may contain multiple employees here. Now, whether it's a one-to-one or one-to-many or many-to-many, it has nothing to do with the merging operation. That doesn't change how merging operates, but this changes what we get as a result. When we have a one-to-one operation and we're merging them, we get a data frame that contains exactly the same rows as each one of these data frames. If we have one-to-many relationship, we're going to get a data frame that contains as many rows as the larger number of rows in these data frames. right? So you can see here that, for instance, Bob in accounting is supervised by Carly. Jake in engineering is supervised by Guido, but that's the same thing for Lisa, because Lisa is also in engineering, hence she's also supervised by Guido. So this resulting data frame has 4 rows, because df3, which is the many side, contains 4 rows. Let's take a look at this example. This is an example of a many-to-many join. Here we have the employee data frame, and this one is a skill data frame. Each group requires multiple skills. So accounting requires math and spreadsheets, engineering, coding, and Linux, and HR, spreadsheets, and organization. If I join these 2 data frames together, and once again, Pandas by default is going to look at the overlapping column, and here the overlapping column is group. It's going to figure out that Bob accounting, then we've got math, but it's going to repeat that. So we will get Bob accounting and spreadsheets. We'll get Lisa engineering and coding. Sorry, Jake engineering coding, Jake engineering Linux, Lisa engineering coding, Lisa engineering Linux, and at the end, Sue HR spreadsheet and Sue HR organization. So we're going to get a data frame that contains more rows than either one of these data frames. Once again, conceptually, the joining operation, the merging operation is the same. Now let's take a look at some of the nuances that we have when we do merging. Again, by default, Pandas is going to join based on the overlapping columns. But many often, we want to specify the overlapping column or the overlapping columns, and maybe there are overlapping columns that we don't want to use all of them, we want to use one of them. Let's take a look at that. Here we are specifically saying, well, join on employee. Now, this is not needed in this particular case because we have employee being the overlapping column, so I can simply omit it. I will get the same thing. But if I want to be specific, I can provide the column name on which I want to join, which is the employee here. Now, when I do the on keyword, the name of the column has to be the same, obviously, across the 2 data frames. But many often, the column names do not match. In this example, we have 2 data frames in which employee name was listed under employee in df1, but under name in df3. So if I want to join these 2 data frames, I need either to rename the columns, or when I do the merge, I can provide the parameters left on and right on. That basically says, take a look at the employee column on the left data frame, which is df1, and match it with the name column on the right data frame, which is df3. And we get the resulting join. In this particular case, this is important. I cannot simply omit this parameter because there is no overlap in between the 2 data frames here. And it's going to give me an error because it can't find any overlapping column, so there are no common column. How would you like me to join these 2 data frames? Now, the resulting data frame has 2 columns, employee and name. I mean, obviously the join was conducted across this 2 columns, so the values are the same. But anyhow, Pandas is going to list these 2 columns in the resulting data frame. If I want to drop, I can use the drop function. I can drop name on the column axis just to avoid this redundancy here. So far, we've been joining on columns, but many often the data frames are indexed. If the data frames are indexed and we would like to use the index as the joining condition, we can use a keyword called index, left index and right index. Let's take a look at these 2 data frames, df1a and df2a. Basically, those are the same as df1 and df2. I just simply index them. So employee is no longer a column in those 2 data frames. So thus, if I want to join, I need to specify that I'm joining on the index. I want you to take a look at the index on the left frame and match it to the index on the right frame. Okay. And again, this is important. Pandas is not going to do this by default. Pandas by default only looks at the overlapping columns. So if my 2 data frames are indexed and I want to use the index as a joining condition, I need to specify the left index and the right index to be true. Now, in the beginning, I mentioned there is a quality of life function called join. And the quality of life function join is a function that you call on the data frame. And join, in contrast to merge, joins always on the index. So if your data frames are indexed and you want to join on the index, an easy shortcut is to do df1.join df2, and it's going to do exactly that. Again, join is a quality of life function. Everything joins does, it can be achieved with merge, but not vice versa. Join only works when we have two data frames that are indexed and we want to join using the index. Now, finally, we can mix and match. Let's say one data frame is indexed, but the other one is not indexed. We can mix left index or left on with right index and right on. So we can say, okay, I want you to use the index on the left data frame, and I want you to join it on the right column called name here. So this will match the index on the left data frame with the column name on the right data frame. Now, in all of these examples that we have seen before, when we are joining, Pandas is looking for the same values from the left and from the right. And if we don't have matching values, we don't get corresponding rows in the merge operation. For instance, if you take a look at these two data frames, the first data frame is listing the, for instance, preferred food for people, Peter, Paul, and Mary. The second data frame is the preferred drink for those people, Mary and Joseph. Now, if you take a look here, you can see that only Mary is overlapping as a value in between the left and the right data frame. So if I join my two data frames, if I merge them on the overlapping column, which is name, I'm going only to find a row corresponding to Mary, because the value Mary is the only value that is common across the column name in both left and right data frames. This is called an inner join. And it only looks at the values, keeps the values that are overlapping. So in all of the previous example up to this one, all of the values were the same. Each employee existed in both left and right. So it was not an issue. But many often, we don't have the situation, such as in this case. And the inner join may be the right decision, maybe not, maybe it's more restrictive. Think about a restaurant or who that would like to kind of do some pre-preparation for if customers come. Let's say your customer come, you want to serve the customer their preferred food and preferred drink ahead of time. If you do the inner join, you're going to miss on the fact that Peter likes fish. Although we don't have any information about Peter's drink, it still makes sense to, serve Peter a fish plate, for instance. Same thing for Paul. And Joseph, although we don't know Joseph's preferred food, it's still, we would like maybe to serve him a beer when he comes. And if we do an inner join, we're kind of losing this information that doesn't overlap. The opposite of an inner join is called an outer join, and this basically preserves values that don't overlap and populate the non-overlapping parts with null values. Oops, let's create the data frames here. Okay. So the outer join here is basically doing the same thing as the inner join. We will have Mary, bread, wine, but for Peter and Paul, who don't have preferred drink, we'll get the name and food, and the drink will be a null value. Similarly, for Joseph, who doesn't have a preferred food, we will get Joseph and Pierre, and we will get food to be a null value. Now, in between an inner, there is left and right joins. Left will basically keeps all of the values from the left data frame, even if they don't overlap. But it doesn't keep the values on the right data frame that don't overlap, and right does the opposite. So if I do left join here, I'm going to keep all names from the left data frame, although Peter and Paul don't have a preferred drink. But if I do a right join, I'm going to get the opposite. I'm going to keep Mary and Joseph from the right data frame, but I'm only going to keep Peter and Paul here. So we have a choice of doing inner, which is most likely what we want to do most of the time, but there's also outer join, left join, and right join. Finally, let's take a look at some of the options pandas provide to deal with the fact that many often we end up with repeating column names. So in this example here, if I join these two data frames on name as a common column, let's say this is the ranking of people in different skills, you can see that the second column rank is also common in between the two data frames. So as a result, pandas is going to suffix by default the column with X, Y, and Z with letters, right? Because both columns now rank have the same name. Now this will not be an issue if the column is called, for instance, rank 1 and rank 2. Now there is no overlap and we will get rank 1 and rank 2. But if the two columns have the same name and we're not joining across those two columns, we're only joining across name here, then pandas by default is going to provide a suffix because otherwise it will be the same column name, which is not possible. We have the option of changing this. If we want to have our own suffixes, we can provide that. So we can say that suffix left and suffix right, and we get that suffix provided for us. I want to end with a topic which is not exactly the same as merging and joining in pandas, but it's kind of related. So if you've done a course in database, you will realize that all of these operations, the join operations, are similar to the ones we have in databases. And many often when we pull data, we have access to relational databases. So far we've been reading data from CSV files and Excel spreadsheets, but it's also possible to interact with a SQL database from Python. If we have a relational database, and that's often the case in many organizations, now we have two options. We can either interact with the database in Python and use SQL, or we can read the data from the database and we use pandas. That's give us some flexibility. And what I want to do here, I just want you to introduce the basic steps of interacting with a relational database in Python. First step is to import the driver of the database. This really depends on the database we use. MySQL, SQL Server, Oracle. For the sake of this exercise, I'm using a database engine that comes already with Python called SQLite. Second step is to establish a connection. Now again, the second step also depends on the driver. Some database servers will have some authentication process, a protocol, other configuration that you need to do. So again, the first and the second step, you need to refer to the documentation of the database server that you're interacting with. For SQLite, it's, as the name implies, a lightweight database server. It basically reads from files and there is no authentication here. Once we authenticate, we can use a function called readSQL. And readSQL will take the connection to the database that we want to access, and it will also take a SQL query that it will execute. So it will execute the SQL query, and then you will get the result in a data frame. So this is kind of important if you have access to a relational database and you want to pull some data from that relational database. You need to follow these steps. Install and import the driver, establish the connection, and then issue the SQL query and get the data into the Python notebook.